QR code to get attendance in. Much appreciated. This is just organized to kind of learn what we're all interested in. A lot of us are interested in different topics, and we have a bunch of different things going on. So this is a good opportunity if you like what somebody presents to go talk to them, ask them about it, and you might find something you like and find something you want to research. So I'll get started with the project that I've been working on for a while now is malware development. I'm mostly working on the Windows side. So I created something called a stager last night to show off today. Does anyone know what a stager is?
Last night you started.
Well, yesterday morning. Finished it last night.
Typical DSU student.
Yeah, exactly. Basically, what a stager is you have a file or shell code, and what it does is it pulls down malicious code from other source, so the malicious code never touch disk. If malicious code touches disk, then it's more prone to getting detected by antivirus. And as you'll see, we're gonna spin up a MSF Venom reverse shell, and it's not gonna get detected because it's staged, it's not on disk, and it's hard to scan. So I'll walk through a little bit of the code. This was a different project. Here we go. So something you commonly do is you declare everything at the top. If you don't know what these are, these data types, basically they're data types that interact with the Windows API. The Windows API is a wrapper for the native API, and then the native API is a wrapper for syscalls on Windows. Kind of confusing, but once you learn it once, it's pretty easy. Right here, we're just initializing some web requests. So this is going to call back to my server. It's going to call back to this IP address, and it's going to grab this file. It takes 5 functions to do that, or API calls to do that. Right here, we're allocating buffer space with virtual alloc. That's just going to allocate space for our shellcode to go onto. And then this do while loop is meant to read the file and store it inside of the buffer. Once we get down here, I basically give the user 2 different options. One, you can either store what you just downloaded into a file, or you can execute it without storing it. We probably want to execute it because you don't want it touching disk and getting it detected. So I'll show off an example of how this works. Keep in mind, it already has my IP address and my port and the file that it needs to grab down. So we'll go in here. We'll generate a MSF Venom reverse shell with, and we saved it as calc.exe, same thing we put into the code. I'll spin up the web server, port 8080, same port it's reaching out to. And then as you see, the L port on this reverse shell is port 4444. So I'll go on here and I'll start up a Netcat listener. This is what the Windows stager is going to call back to. And we execute it. Right here, it kind of shows you this is the address it allocated the shellcode at. This was the size of the shellcode. And it kind of prints out the first 300 bytes of the shellcode for you to look at. I think it's kind of cool to see the payload. And then we'll go ahead and execute it. As you can see, we successfully have a reverse shell. We can get PowerShell, we can get commands. So these commands are running on this Windows machine. And usually, if you just drag and drop the calc.exe file that we made onto the Windows machine, it will be immediately deleted by Defender. In this case, it's not because it's staged. It's only stored in memory. It's not on disk. It can't be scanned. Right? And actually, Defender will do something called dynamic scanning. It will realize that a reverse shell is going on here, and it will kill this process. But I figured out earlier, it just kills this process, and this thread keeps going. So it doesn't actually kill the malicious part of it. So yeah, that's kind of what goes into malware development. I can go over some of the, if my browser wants to open up. No browser, I guess. If you want to learn how to do this, there's something called the Win32 API. With this Win32 API, basically everything in my program went through this. There's a windows.h header, so you would do include windows.h, kind of like you do include stdio.h. And then you call all the different APIs. And then there's also a resource that I use called MalDev Academy, basically on this website. It's a paid resource, but on this website, you have all these different modules that teach you how to do various different malware development, etc. So yeah, with that, you can go into the next project. Who's up next? Ryan? All right.
Maybe. Yeah, there we go.
Do you want to share your screen in Discord?
Yeah, I can.
Make sure you mute and deafen yourself too, so it doesn't keep it.
Alright, let's look.
Looks good, yeah.
All right. So this is my project. It's a C2 server called WhisperNet. How many of you are familiar with C2 servers? Raise a hand. All right, we got a few. I'll give you a little bit of background on how they usually work first and get an idea. So a C2 server is effectively just offensive infrastructure. You usually have your agent, a server, and then some type of interface with it. The way mine works is that I have obviously the server, the agent, which is written in Rust, and then the actual web interface. Ray just showed you a really good example of what an agent could look like. His is just a reverse shell and kind of the start of the malware process, which is pretty sweet. Let's see here. All right. So mine is currently hosted on a Kali box I have, and this is the web interface. So I'll log into this real quick. So there's a couple few main things I want to show about kind of what this can do. The first being the reverse connection that you get when you successfully put a payload on a box or do an exploit and get a shell. So I have my payload right here, precompiled and everything. Just go ahead and theoretically, oh, come on. Get a shell here. I should note that I have Defender off because my payload, unlike Reigns, can't defend Defender at the moment. So if we give it a refresh, and here we go, we've got a shell. Oh, that is the wrong one. So we can run commands in this sudo shell and do some other things. C2 servers kind of shine where things are supposed to be hands off and kind of not script kiddie, but also just easy. Some very well built out C2 servers like Cobalt Strike make it easy to, for example, like pass a hash or just dump creds by just right clicking on the device that you have the malware on, and it just does it for you. Mine doesn't do that yet. Currently, it just has two commands, PowerShell and the command, which just runs cmd.exe. So this is like super handy for like red team engagements where you have, I don't know, like a year-long engagement going and you just need something that's usually stable and going to be there for everyone to use. It's like multiplayer offensive security. Because multiple people can log into this, interact with the boxes that you've gotten shells on and stuff like that. The other part that I just recently fixed like an hour ago, oh, maybe? Live demos, I swear. Oh, that's why. Okay, hold on. All right, I think we're still good. There we go. Is this binary build process, which makes it easier to just choose certain options for your malware and just have it work. Ideally, in the perfect world and after a little bit of work, the agent that I just showed you that connects back to the C2 server will be able to be built with this as well. But for now, I only have like a custom shellcode runner, which works, which is very, very similar to Reigns, but written in Rust, and is a lot less lines and a lot less chaos. And I'm kind of giving him crap because he was giving me crap earlier about it. So very similar in terms of Reigns, except for this one doesn't actually reach out to the internet. It just loads the shellcode you put here, and I'll show that here. So this is some shellcode that MSF Venom did, and all it does is pop calc.exe, select the custom option, pop in the shellcode, click advanced options, which doesn't actually do anything except for choosing your method of how to load the shellcode in, and then hit Q for compilation, and then just give this a second. And in the background, there's a whole Docker process working that will go and build this actual payload itself, combine the stuff, and then spit it out to you. But that it's a bit too in-depth for going into it in this time slot. But if I refresh here, there we go. Get our build log, and then the default name.exe. And this is going to be our payload. And if we double click this, it should, well, ignore smart screen. Should go ahead and pop calc.exe. And that just did it directly from this shellcode. So in a nutshell, this all got placed into exactly right here, compiled, and just runs on Windows and with Defender off. because this does get caught. So yeah, in a nutshell, that's my C2 server at the moment. It's got a lot of work to do. If you have any questions, just let me know. I'll happily talk to anyone about it for like probably hours on end. So yeah, just let me know. All right. Who?
Mine's a lot more boring than those two. I don't know. I started this a couple years ago. I basically tried making a little challenge to make a custom math library without any pre-built math functions. So I just tried to use add, subtract, multiply, divide in mod. And I'm like, hey, how far can I go? Essentially. Let's see, will that appear? Okay. So I guess maybe to milk the time a little bit, I could explain to you like how I did these. So what do you guys think would a square root be? Like, well, what would you guys think a square root would be?
Do you wanna share your screen in the Discord?
Oh, sure. How would I do that?
Just join the club meetings voice channel in the computer club Discord, and mute and deafen yourself just so it doesn't have any
So
feedback.
the club meeting, just add myself,
Yeah, and then just share your screen in it.
and that. Cool. Is that it, right?
Can you share your screen?
Oh,
You have to click the button. The right where it says video connected on the bottom there, the second one from the bottom.
bottom.
Oh,
Sorry.
to the right.
Yeah.
Nope, left.
This one should. Okay, sorry. I'm not
And
Discord.
just do screens on the top there.
Okay. Screens back. Sorry. Screens. There we go. Screen one. Okay.
And then go live.
Go live. Okay, very epic. All right. Thank you for that. All right. So, to milk the clock a little bit, do any of you recognize those functions up there in the calculator? How many of those do you guys recognize? Yeah, that was probably one of the last ones that I made. It's for some crazy Lambert W function. If you look it up, it's for some unliquidable integral something. So I kind of learned as I made along. So, like the square root, how do you think you would program a square root without just having? What do you guys? Any
So I would raise it to 1/2.
Yeah, but like how would you do that if you didn't have that ability? If you could only add, subtract, multiply, divide. That's the idea there. So
Square and neighbors?
you could do that. Was there like more efficient one? You guys, anyone? Efficient search algorithm that would efficiently search for the sorted collection.
Binary search?
Yeah, exactly. That's how I approached this at Watch. This is like the first one I built. Over time, I may have changed it to the Newton method. Anyone hear from that? I think Ethan knows about that. That's how I did the later ones. But basically, yes, I do a binary search, but there's a little caveat to the binary search. Because you know, the square root, when it's less than 1, it's actually bigger than when you do it. So, because like the square root of 1/2 is like 0.7 something. So you have to be careful where your max starts and stuff like that. But yeah. And also, probably my pride and joy is the sine function. So how many of you guys have taken like a trig class before? Anyone? How you guys are rusty on those things? So how would you guys program a sine function? Kind of like the wavy function. If a line. How would you guys program something like this? What would you think your first step would be?
Basically trying.
Yeah, exactly. Yeah. But this is like plugs in all things. So, what's up?
Find an approximation of like a single waveform.
Perfect.
Use modulo to make
Yep.
it scale.
So you can use modulo to cut it a lot. So you see it repeats over and over again. So you can do mod x comma 2 pi, and there you can cut down. So you just repeat the same function over and over. So how many people have ever taken calculus before, or calc 2 or anything? When you did that, you have to think about the Taylor series before. So that's one approach you can take. So a Taylor series is basically polynomial. So you can have like x minus x cubed over 6. So this is the one for sine. So if I do an infinite amount of stuff right here, if I just keep doing, see it builds closer and closer. And if you guys look in like the C source code or whatever, that's how they do it, or some Ethan probably knows more, probably. Okay. But basically the approach I did is using the sum and difference identities. Have you guys heard of those? No one? Okay. The sum and difference angle identities for sum.
Not that I know of. I may have seen him, but I don't see him.
Alright. Does let's see, organic chemistry teacher? Cool. Very based. These ones look familiar? There we go. So essentially, I combined the strat with the binary search thing. So I basically have an angle. There's also a thing called a half angle identity. Have you heard that before?
Yeah,
So basically, I have an angle. If it's too big, a single will be the other, and I cut it in half, and I use some difference to add it up. Then I cut it in half again, try to add it as closer as I can before I'm happy with the approximation. Because it's all approximation, because of floating points. You can't do infinite, unfortunately. Very cringe. But if you guys are interested in the source code, like, let's see. Right here. So what do I do first? What's that first thing right there? Right there, anyone?
Wait, what?
The first thing with my cursor is. So what's that do? It like limits the range and stuff. And then right here I have a little step angle, so I start from angle pi. Everyone here know the sign of pi? It's like a pun joke kind of. No one? Radiance?
Forgot.
It's
I
zero.
blocked all of
That's why it's healthy as much pi as you want, because it's zero. Sign of pi is zero. It's like the sin, like it's not. Can't really think that, but some joke goes like that. So eventually I cut the angle, keep cutting in half, using half angle identity. And just kind of keep doing it until it gets close enough. And to make sure I'm not lying to you, what do you want to find the sign of? Radians, please. Do you want to do what number? Anyone got an idea? Any suggestions? Zero. Zero, because you're not really doing anything. Anyone here want to do a natural log of something? Please, possibly.
2.718.
2.7. Why? Why did you just pick that very specific number? I wonder.
It just came to me.
Just came to you? Came to you in a dream?
Just came.
Whoa! Look how close the number is. Does anyone know why?
Isn't that E or something?
Yeah, very close. So anyone else have any questions or anything? Sorry, it's a little more boring than the two, but any more function suggestions you all want? Actually, hold on. For all the C gigachads in the room. One second. All right. Does anyone recognize what this part? What is this parameter? What does this mean? What does this cursed abomination of pointers mean? Anyone have an idea? So who knows what derivative is? Right? Anyone here? All right. So if you say dx, what do you have inside? What do you think is going to be inside? Anyone have an idea? What that cursed first parameter is? Exactly. What would be more specifically in C called?
Structure.
Not structure, but you're very close to function. A pointer to You're really close. There we go. Function pointer. Yeah. I remember I did that. I was on the DTD's website. I'm like, wow, that's a thing. Wow. That's how I discovered that. All right. And anyone have an idea? Let's see. Delta X. Anyone have any idea what that would mean? No one? That's the whole dx thing you have in your integral or your derivative. It's like the thing, put as small as you can, but I don't plug it as 0 because I don't want to divide by 0 because that's cringe and the computer will freak out and have some, I don't know, undefined behavior or whatever. What is it? IEEE, I don't know. Man. Okay. Anyone have questions or am I reporting something more cool? Look good? You guys like, wow, this dude. This is the worst. What's up?
For your binary search stuff, like
What's up?
your square root
Wanna see it?
design where you're using binary search to find the
Yeah.
answer, how many iterations does it take on average, and why is it 53?
Hold on. Wait, I gotta find, wait. 53? Hold on. Hold on, let me find, hold on.
I
It's been a
suppose
while.
53 would be the worst case, not the average, but
Yeah.
Would
Okay.
it depend on the required precision?
Yeah, I
Yeah,
kind of
that's-
just. So
that's
wait,
where
where do
that
I have
number comes
53?
from.
Sorry.
that's the number of significant bits in a double.
Oh, gee. Oh, yeah, that's pretty interesting.
So I gotta find it. I use square root a lot for like the trig ones too. That's like probably the most used. I gotta find it. Sorry, I lost it in my own.
Maybe try searching for double space square root.
Yeah, that's a good idea. Let me. I can find that out for you. Right here. Okay. So here it is. So you're wondering why it's 53, or what? Whereas I know a while ago, kind of.
I'm just curious to see if you'd ever like tracked the.
Nah, yeah.
the
Sort of. Like I had some weird bugs with the thing. But not really. I just kind of a while.
Does it ever go infinitely, or does it always?
I had troubles with that. That's why there's like some little error things. That's why I learned the hard way not to use equality with floating point numbers.
Yeah, because I do see you have like guess times guess doesn't equal x. So like eventually it does
Yeah.
terminate to floating point precision.
Yeah, it does. So sometimes, yeah, that probably. I don't know what to change that one. Yeah, you're right. I could probably fix it. This was one of the first ones I made. I haven't really updated it because the later ones I use better things. Like if like the other ones I use the Newton's method, like derivatives and stuff to solve stuff because it's much more efficient than a binary search. This is like my first function I made here. That's why things still years back because I continue to add to this. But yeah, anything else?
So how bad it is compared to native instruction?
Oh, should we want, do you want to benchmark it?
Sure.
Sure, screw it. Let's do it. Hopefully, not taking too much time. Is it taking too much time, Rain?
I think we are using hour in 7.
Okay, should I step down? I can benchmark, or what do you want me to do up here? What do y'all want?
Just square root should be a single.
The square root has hardware
Instruction.
acceleration in x86 now, so.
Yeah, with
So,
It's-
you think it'll be
it's
faster?
literally
You
equal
think it'll be faster than Wild Loop?
I'm really sorry, John. You have like 4 branches in that thing, absolutely murdering the instruction pipeline prediction.
Okay, hold on.
I
I'm
never
sorry.
engineered twice.
So we want to benchmark. Okay, hold on. Is it? How do we get the current time?
I don't think you'd have to use like
Oh, someone
part of their,
joined.
like Unix standard one instead of the regular time.
That's it, not running that crap. So then if I just don't just put it in the garbage or whatever, and then do I have to include math then?
Yeah, but
Or
that'll
That'll
trigger
name they'll
access
name
chain, yeah.
issues.
I
Okay.
think maybe not.
I'm gonna,
Maybe do it once.
maybe we'll do it
John
after.
Put it in the chat.
Yeah, you put it in the chat. Yeah, we can have the benchmark, and I can cheat and stuff. That I could. I'll comment it out and be like, oh, you see, they call it. All right. I think that's all. Any more questions? Challenges? Anyone? Everyone's like, oh, I'm leaving. This guy sucks. Anyway, thank you all. What's up?
That's
Hmm?
that's half your problem.
You can basically, well, I actually came in just basically questions.
I
I don't know if it's gonna clone it or if it's gonna just expand. Okay, cool.
You want to share your screen in Discord too?
Yep. Okay, how's that?
There it is.
So, as you guys probably know, like outside of like security related stuff, I'm also really like into like self-hosting stuff. So in the name of like privacy and all of these other things. So I wanted to share like the home lab that I've been building. I started this guy probably, I think I was like my junior year in high school. So that's probably like almost freaking 7 years ago, which is crazy. But yeah, so pretty much like for you, if you don't know what it is, a home lab is basically just alternative that I daily drive that is completely offline and it's like on my own like hosted hardware. I have like all that stuff set up. So it's been really nice. Kind of like cleaning up a lot of the stuff that I actually put out to the internet. But so this photo here, that's sitting at right now, it's not actually in the bathroom. When we were moving dorms, I just wheeled it in there because I thought it'd be really funny. This guy here, you can't really see it very well, but maybe you can. That is my very first like implementation of the home lab. So that was probably like 2018 or something like that when this photo was. Yeah, this was a NAS at the time, but anyway, in my rack, there's another bathroom photo. So right now, like all I have is a 12U server rack. So I have a patch panel, PoE switch, a PPF sensor router, the Proxmox server, and some other things like that. So the networking side of things, so it's actually kind of, all of my networking stuff actually has kind of a funny story. Oh, I didn't finish this part of the slide. But my PF Sense router, so when we went to DEF CON for the AI Red team, they gave us like $400 in whatever we wanted to spend it on. Because we wanted to spend it on like a village or something, or if we needed food or anything like that, you can use that money for that. Well, I ended up like starving myself the whole time we were in Vegas because I wanted to spend it on home lab stuff. So I was like barely eating a meal a day, and I was able to build out this guy. So it was totally worth it. I'd do it again. But basically this is a ThinkCenter M720Q. What's really cool about this guy is that it has an X16 full like PCIe slot inside of it. So you can get like a 90-degree adapter and you can throw like a whole graphics card in there if you really wanted to. And the thing's probably like that big. I ended up putting a dual 2.5 gig NIC inside of it. This is my switch. It's not taken apart. I Noctua modded it, so I just took Noctua fans and put them on the inside because it was much quieter and moved about the same amount of air. That one's really fun because when I was helping, basically, I think it was one of the tech support guys in my high school. When we were like getting ready to close a shift or something, he's like, "Hey, I have a switch. You want it?" Like, okay. So then I've just been using it since. I have 2 access points. One of them, so this one on the left or on the right here is, I think I was talking about that I wanted one, and then my boss Aaron came to me and just dropped it on the desk next to me. It's like, here you go. I was like, oh, perfect. This one, I was not sober when I bought this. We were, we went to Minneapolis for the Cyber Summit Challenge, and the van that we were in, with like Andrew and everybody, we ended up making like a Goodwill run, like right after I had a lot to drink. And I found this router, it's a Wi-Fi 6 router, and access point, and it was like $4.30. So even if I was drunk, like it wasn't a bad idea. So that's the networking side of it. A lot of it is 2.5 gig. The switch is really the only bottleneck because it's gigabit. I'm just waiting for it to die, and it hasn't died, and I've been running it for like 6 years straight. So I don't know how long it's gonna last. Yeah, the uptime is wild. I don't know the exact number, but my primary server, so this is a custom built guy. So this is a 2U, like inside of a 2U case. I'm not sure how dark that image is. Yeah, so it's like just normal consumer hardware stuff. I used to have a Threadripper desktop, and that was way too overkill, so I ended up downsizing, and mostly for like efficiency and stuff. So I have a 600Z, 128 gigs of RAM, the best NVIDIA graphics card ever made. Maybe that's a hot take. The A3000, and then I have 2.5 gig NICs in here, and then I have what's called a Blackley VM for out of band management, so I can power the thing on, I can turn it off. I can access the BIOS and all that stuff completely remotely. I don't need to be anywhere physically near the that has a network connection. I can basically do whatever you can normally, like as if you were actually interacting with the hardware itself. Mirrored boot drives, all that stuff. I do like being really janky with stuff. So this is the BlackAVM controller. You can't really see it very well, but I taped it to the side of the power supply because I needed to use a slot to fit the graphics card. So being janky is fun when you have home lab stuff, but that's pretty much what the inside of it looks like. One of my favorite things is this case came with 2 5.25-inch bays. So you it was normally for like DVD drives or whatever, but you can get like these 5.25-inch bay adapters. So I bought 2 of them, and now I have 12 hot swap SSDs in front of the server, which is super nice. So it's just little things like that. The services that I usually run on Proxmox, this isn't all of it, this is just kind of a high level just for time and stuff like that. But I run TrueNAS as my primary NAS, that's this guy right here. And then I have 6 terabytes of storage that's in a RAID Z2, so it's actually 4 terabytes usable. Anyway, and then Docker, I have like Plex and Jellyfin, Kavita, Nextcloud, same thing, all of that stuff, Terraria. So basically, like anything that would probably be, so like streaming services, I do all of my music, so like Spotify alternative, I guess you can call it. I do all of it through this. I do all of my like TV shows. I do all of my movies. I do all of this stuff through just whatever's on my server. SyncThing, I use it to sync multiple devices to the server. So, for example, like my Obsidian Vault, this guy right here, that moves across like any device that I connect it to. Pi-hole is for network-wide ad blocking. I have a couple of different servers and stuff like that. I have a Windows 11 machine. Well, it's both of these. There's one of them is Windows 11, one of them is Pop! OS because I'm currently moving stuff around. But I use it for my LLM, so I use this basically more than ChatGPT nowadays. I use Stable Diffusion rarely, but it's there. And then I do cloud gaming a lot, so most of my gaming is actually just me remoting into the server or some other desktop that I have already and doing everything from there. And then the main one really is just like isolated environments. I would say probably I did clean this up a lot, but most of it is mostly for like offensive security stuff. So I do a lot of like my learning on my actual lab. So that's kind of how that goes for my stuff. So below it, so that's this silver guy right here. This is my backup server, so I have an N11U. I have plenty of storage, as you can see. But it's running just super low powered Celeron, and maybe this is another hot take, but I think the low end stuff for newer generations of CPUs are way more interesting than the high end stuff because the amount of performance that they pull out for like no amount of power is ridiculous. So this is a really, really lovely Intel CPU. But yeah, basically this does all the backup handling for the entire 2U server. I back up my Mac on that every day. I actually just got a message, like a notification from my Mac saying that it couldn't do it because maybe there's a little bit of space that's it might be a little bit low, but stuff like that. And then you always got to stay jank with things. So this was actually a photo I took this morning. I said, y'all aren't ready for the garbage I'm cooking up for this final project. I have 2 desktops and it's like in complete shambles, like right underneath my desk. And then this morning I installed Proxmox on it, so it's Buddy's officially a server. But yeah, like this is what it actually is. So this is my TrueNAS, Docker, Pop! OS for my LLM stuff, all of that. We can do like, hello, tell me a 400-word story. Yeah, I just use Gemma on Ollama for all of my LLM needs. And you can tell that it's internal because I'm VPN'd into my personal network and that's running on my host. But yeah, like other things in here, I do some extra Docker things, offensive security, GoAd, all of that stuff. But this is, yeah, I don't know, I kind of wanted to share this because it's not quite security related, but does consolidate a lot of like the experience that I gain because I get to play around with stuff on here. But yeah, like, does anyone have any questions or anything? Or yeah.
Nervous about messing up like the NAT stuff like that. Like, how do you go about doing that without breaking your router?
So I do everything behind NAT. Oh, I guess I had this. This is like a super. This is not like super comprehensive, but basically, I just have the router connected to DSU thing, so they do all the firewalling for me. I'm gonna have to fix that once I move out. But I do everything behind NAT, and then I kind of keep it exclusively internal. And then the way that I access it internally is I just use Tailscale. So instead of opening like a port for like OpenVPN or WireGuard or whatever, it does what's called NAT punching. So you don't have to open anything; you can just go straight into the network. That's the way I do it. It's really easy, and I haven't had to touch it in a couple of years, so I just kind of haven't really bothered changing anything. But yeah. Any other questions or? Yeah.
So an estimate like cost of it.
Oh boy. So, oh god. So I think honestly, okay, so it's probably not as bad as I'm thinking it is. So the router was completely free because I used that by not eating. The switch was free as well. The rack and like everything else. So rack mount components are relatively expensive as is. I think when I built the 2U, my budget was like, I think it was like $1,200, and I think I ended up breaking like 3,000. So that was a little bit rough, but it was totally worth it. I'd do it again. And then the backup server, the little 1U guy, I think that one might have been fairly like affordable. I think it was probably like 4 to 6. It wasn't bad, but I think it was mostly because I already had the hard drives lying around. But yeah, total cost, I haven't even thought about it. I don't even know. There are people who spend way more than me on it. I try to be extremely frugal, like even when I am doing stuff like this. Like I try to have everything on one host as often as possible. So I'm not like some other people who have like 42U racks and they have an entire server that pulls like 10,000 watts for just a single task or whatever. But I honestly, I would say probably at least 5 or 6,000 if I were to throw a number out. I'm really not sure though. But yeah. Any other questions or cool. Here I will stop the
Would you not to use PC? Yeah. Okay, because you not to use PC in front of you.
what did
As soon as you unplugged it, the camera started.
Dang.
Should I join the Discord?
Yep, just join the club meetings chat and then mute deafen yourself,
yeah.
share your screen.
Okay. Share. Yeah, they changed it on Mac OS, so it's now share and touch screen.
You gotta deafen yourself.
I think I did.
No, you didn't. You
Oh.
just muted.
If you have your volume all the way down, you're fine too. It's mostly just so it doesn't play out through the room
Okay.
speakers.
Well, who here likes games? Yay, let's go. Everyone was at NanoCon, so I'm guessing everyone. Okay, who here loves procrastinating on Wikipedia?
Me.
Yeah, some people, right? So if you like games and like Wikipedia, or you were in high school also, you might have played the Wiki Race. If you don't know, basically, you start a game, create new lobby. This website is actually really awesome. You can very easily join from multiple other people just by using the lobby. Please no one join the lobby. But basically, yes, you select the start Wikipedia page or just select a random one and you try to, it will launch you into this page and you need to make your way to Andy Garvin somehow. Well, I'm really bad at this game and I lost a lot, so I'm not gonna do that. And plus, usually you run with something a little more prominent, like, you know, you type, please for two, you know, either to Owl Hitler or like, we really like to go for USS Giats. Yeah, this was an interesting time. Anyways, there's also this online game that's like continuously running for the past 14 years. They have rounds every 2 minutes and people still play it. And get like insane points by playing every day, which is kind of anyways, I like games, but I like winning and I don't really like playing, so I made an algorithm that finds a way for you. So basically, let's imagine someone did join. All right, guys, let's play. Sure. All right, I'm playing against two people. All right, so we'll launch this. It grabbed our original page. Let's copy. Okay. Okay. I think we found the path. Republican, sure. Arabs, sure. This, sure. Okay, this, sure. Yeah, guys, I think I won. And you didn't make it that far, so I'm great. So yeah, basically,
The same without.
this is how it works. I can show you more details. It's written in Java, obviously the best programming language out there, which you should really learn.
Correct.
Okay, the actual reason is you might have noticed that the actual execution time was only 1.67 seconds. And I've done some benchmarking on this on my GitHub, which you should go and start. Basically, my average runtime, the median runtime is less than 2 seconds and a little more than 2 seconds for average. And when I started this project, I thought the runtime would be in tens of seconds. But it appears that Wikipedia is a lot more interconnected. And even when trying to raise, I think Wikipedia has like 7 million articles now. Even if you pick 2 random articles, there is a lot of interconnectedness and it's easy to find a path. The actual algorithm it uses, we need some kind of proxy for what would be a good article for Wikipedia game. So you want something that's prominent. So if you start from just like random articles, like right here, you think that going to like Republican Party United States or President of the United States is a good pick. So you want something prominent. And the 2 variables that are used to proxy for that is article ID, which is vaguely correlated to the creation time. And you would think in the lifetime of Wikipedia, more important things were created earlier. And the second one is article size in bytes. And from that, we basically get the priority. And I have it set up to explore 4 articles in each direction. So it picks top 5 articles which have the lowest ID and the highest size and tries to go deeper into them. And it does it in 10 threads at a time, which is actual reason why I picked Java, because it makes it very easy to make it run concurrently. And this is what provides a lot of the speed up. Because a lot of the time spent waiting on this continuous Wikipedia request absolutely hammers their API, which they don't appear to have a very strict rate limit on, which is great. So that allows it to run this fast. And you can see at the end, it was evaluating 1,600 articles on one side and 533 articles on the other side, and trying to find this connection. What's interesting is that someone like Mac actually made a proper approach, because Wikipedia publishes their data dumps, so you can download the database of all the interwiki links and just do a graph search, and I mean, it's a solved problem. So someone built this. And you can click on run. Yep, 1.2 seconds, a little faster. It actually finds all the paths. And you see the shortest path had 4 degrees, so it's length of 5, and our path was of length of 6, which is basically what I found. On average, this algorithm is only 1 click off, so only 1 step off. I had it in a benchmark, which was really surprising to me, again, that on average, it's actually a hair higher than 50% of the time. It's actually the same length as the most optimal, the shortest path. But usually it's 1 to sometimes longer if it gets a little lost. So yeah, I found it very interesting. It came out way better than I expected. And it's probably one that I'm most proud of how well it works. Yeah, if you have any questions. Sure.
I know recently I saw a video about like when they made a graph of all of Wikipedia.
Yes. This video came out as I was working on this project.
Okay. Wow, that is a fundamentally cake. It's like really when you get to it itself or some weird thing.
Yeah, a surprising number of Wikipedia articles are isolated. Like I run a lot of runs, and I think the failure rate was around 2 or 3%, just because there isn't an actual path.
Website checked it, and they try to do one that doesn't have a path.
This is actually a big difference, because the website uses a data dumps. They are only updated every 20 days. So I did run into the issues where it was using an information that's no longer up to date to Wikipedia.
Okay.
Or some other issues. Another thing with the size of the graph you have to download with all the links is about 10 gigabytes, and I had to be loaded into memory. So for people who are misfortunate enough to buy a Mac with only 8 gigabytes of memory, you literally can't run a proper algorithm. Meanwhile, this uses a lot less RAM, and it's using the API, so it's all current data. So obviously it's better. Yeah, sure.
Do you think that, because your heuristic function that you had here was based on the length of the article and the number of links that it had in it, right?
The length and the ID, which is, yes.
Earlier creation time.
Yes.
Do you think that there's a different heuristic that could get you maybe better results?
I mean, probably. The thing is, there's only a limited because when you fetch all the articles from page, you can add which parameter for each of those articles to get. There's only a very limited amount. I tried experimenting with the coefficients, but regarding that, even it's not a thing that I can benchmark a lot. I tried to figure out the coefficients, and 1-to-1 worked out best. Just my ID is just article size minus article ID higher. There's probably a better way, but this one was the most logically consistent. Maybe there's something better, but yeah, I was surprised that this works as well as it does. Yeah. Oh, and the whole Chrome following, this is only works on Mac because it uses Apple script. With this, and I wrote some JavaScript that lets it highlight, like find the link on actual page, highlight it, and plays a little wow sound at the end. So learn JavaScript. It's useful. Yeah.
Thank you.
Did you hear the USB-C? Well, if you have the USB-C plugged in, you don't need that for the HDMI.
I don't put the HDMI plug in.
Oh, because it breaks the camera if you plug the USB-C in. So it'd be better if you have an HDMI port.
Yeah, I got the HDMI port.
Okay, thanks. Because like the USB-C is connected to the same USB as the camera, and it like overrides it.
You can see that's fine. So Minon is GNS3. GNS3 is a network emulation tool, so what it allows you to do is build out networks in depth using client machines, routers, switches, servers, whatever you want. Whatever you can pull an ISO off of, you can put into GNS3. The most common networking emulation tool you guys might be familiar with, if you take a network one, is Cisco Packet Tracer. That is another network emulation tool, but versus GNS3, it's a simulation tool. The best way to say it is basically think of Docker versus a VM. Now, these are a couple of images. So the one on the left is GNS3, that's the one I was going to be talking about, but to give you some perspective, on the right is Cisco Packet Tracer. But there, that's Cisco, and then on the left, that is GNS3, that is an Exos switch VM, that is a Dell router, a virtual PC, and a Kali Linux box. So how does it work? It is like I mentioned before, it's a virtualized environment. So what that means is it's a VM. GNS3 in itself is a VM. Everything inside of it is VMs. So it's nested virtualization. And how it works is you have to pull over the software. So GNS3 will offer some of the different appliances, but you have to pull over the ISOs, which is the actual software that allows it to run. So there are many different ISOs you can pull. Some companies actually offer off of their website and offer free ones like Dell. Dell has a whole book full of like different Dell devices. I currently pulled off one of their 10 series and I have a whole file for those. Extreme's another good example. Extreme Networks, great time to get experience with their Exos switches and their Boss switches. There are also images that are pulled from the GNS3 marketplace. GNS3 has a marketplace full of items you can pull from FortiGate, Proxmox, I think Palo Alto possibly. They have a whole list, and then there's Cisco. Some ways to get the ISOs, though, sometimes you need to get
business, like have a business email set up, like FortiGate sometimes hide it, so does I believe Juniper. And then some companies hide behind paywalls. Cisco is one of the biggest ones. To get their software, you have to pay for their master file, which sucks. There is a guy I know right now on GitHub I found that actually has a whole book full of ISO images from Cisco, FortiGate, Proxmox, whatever you can name it. He has a whole ISO list full and of the newer versions. Downsides. GNS3 is a VM first and foremost. And with it being a VM and all the machines, it turns into a lot of massive virtualization. So it can be extra taxing on machines. So it's important to have a high CPU and RAM to be able to run it. You can also get to run on lower ones. It just won't allow for as many machines to be running. The more you start up and spin up, it's got to give the RAM and CPU out evenly. And like I also mentioned before, like there's getting certain VMs like Cisco, it's a pain due to all the paywalls. And unlike Cisco Package Tracer is a great tool to get into networking because it's with it being a simulation, does not tax your RAM, does not tax your CPU as much. So it's like it gets you in and you think, okay, do I want to get into GNS or do I want to get more into networking? Upsides, gives you hands-on experience. What do I mean? It gives you experience making real in-depth networks using other tools other than Cisco. It gives you experience in learning new topologies, so OSPF, RIP, EIGRP, IS. Gives you different ideas like testing if you want to run a layer 3 switch, if you want to run a DHCP server on a switch or a router versus running it on a server. Learn scripting because you can do bash scripting, you can learn Python scripting off of those because it is the whole software. Allows you to get trained on net certs, whether it be CompTIA, CCNA, learn routing, switching, subnetting. You can learn how to troubleshoot end user devices like PCs. Layer 1 through layer 3 troubleshooting, so physical, data link, and routing. Can learn you like with some of the servers because you can even pull over Windows Server, Linux Server, so it gives you a chance to learn like sysadmin. And you can learn Windows and Linux machines. Now it can be run on many applications, Hyper-V, VirtualBox, VMware, Proxmox, Linux, Bare Metal, OrbStack, which is the Mac version of Docker, and there are many more. I struggled to get run on Hyper-V and VirtualBox. If I probably spent more time, I probably could get it working, but there's a good chance you can get it to work on those. I never got to work on my Windows. I got to work on my Mac just fine. But don't let that intimidate you. There's plenty of videos and different troubleshooting techniques how to get them to work. And unlike other network emulators, because Cisco Package Tracer has a more in-depth simulation tool that is paid for, this is free. And then here are some examples. I can pull up some of my other ones I have. Like here, this is a small Cisco network I'm working on right now using OSPF. And then on that middle router all the way up there, I have it as a DHCP server using tunneling down to that router and that layer switch to give out the IP addresses to those two PCs and VLANs. And I think on another network, I have different things set up to like Ether channels. Then here's an Exos network I'm working on right now, building out. And this is probably one of the best, I'd say, VMs to get started with because it's free, easy to learn how to use, plenty of networking guides on how to use them. And they do different things. They do some topologies different like OSPF. This is another Exos one I'm using, building out OSPF on it. And this is a giant ISP network. I just recently updated this and I added more routers to it to make it more like a real simulation of an ISP in different businesses. And right here, I just built out a small little test network using Cisco devices to build an OSPF network. So I want to ping from the left laptop all the way on the left, all the way to the right. It's a great way to get experience and learn these different troubleshooting techniques because being more marketable, especially with networking, it helps a lot, especially if you end up being help desk for a while. It teaches you a lot because you can learn how to troubleshoot some techniques just on your own. And if you get into networking or you decide you like networking or in here for networking, perfect time to learn all these different machines, gain more experience with it, and learn how to build out these topologies, learn how to troubleshoot topologies, learn scripting, learn a whole lot of different things. And then, like I said, Cisco, also really great option as well. Since this being simulation, doesn't tax your machines as much and works just fine. But yeah, there's a lot of different things you can do in these. And the nice thing is you don't have to constantly save this, you just have to save your machines. Let's see if I can open up the ISP. And like this, like if I were to turn this on right now, the RAM and CPU would jack all the way up to, CPU would probably go to 100%, meaning it's using all of my cores, and then the RAM would go up to probably a max of 80%. And out of any like desktops I've seen this get work on Mac usually handles GNSE very well. I have not seen much with Windows, but that is one of the major things I've learned with this. Any questions?
You want to go one more, or? Okay.
Oh, box.
I got the box.
No, what's this?
So I do not have a presentation aid, unfortunately, because my computer actually in this meeting right now. I don't think most of my stuff needs one, but we'll see. So this might look familiar to you if you pay attention to the DSU projects channel in the Computer Club Discord. This is an old it's a black and white CRT. I picked this bad boy up in a garage sale in North Dakota about 7 to 8 years ago. It was sitting in somebody's barn on their farm for since 2005, I think. That's when the date is, like the copyright date. It stopped working. I got it to work once. It did not work past that. So it is actually too old to the point. It's old enough to the point where it doesn't support digital broadcast. So there is actually it's not on it right now. I had to take it off, but there's a little antenna. If you remember these things on old radios, some of you might be too young for that. But this thing actually supports like TV over the air. It's got a little antenna in it, but it's so old it only supports analog broadcasts. Those stopped being broadcast in 2008, I think, sometime around then. So this thing has been obsolete for over a decade and a half at this point. But it's got a little CRT in it, which is kind of cool. The interesting thing about CRTs is that they work differently from a traditional screen. I guess these are technically the traditional screen, but the screen most people are going to think of, like an LCD, for example, is going to have a whole bunch of, it's going to have a big matrix of pixels, right? You know, you get pixel, 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 and like they're all in a row and column. So there's a very finite resolution. You know exactly what you're going to be able to display. The interesting thing with CRTs is that the resolution under certain circumstances can theoretically be infinite because they don't actually have pixels. CRTs don't require rasterization in order to output an image like an LCD or an OLED screen does. So what
about the phosphor density?
Yes, that's why I said under specific conditions. Because if your phosphors are, it's kind of like film, you know. If your phosphors are absolutely massive, you're gonna have big grainy picture. But if your phosphors are relatively small, you're gonna have a decent sized picture. The thing with most CRTs, though, and this is going back decades and decades, back when TV was first standardized, is the broadcasting standard for television, at least in the United States. Europe and other places use something different. But in the United States, we use a standard called NTSC. I don't remember what that stands for, but it's called NTSC. And the way NTSC works is by modulating pulses over your signal, right? So you'd have your NTSC signal in, and then comparing the brightness for each pixel on the screen, you know, you'd go up or down depending on the brightness. The thing with NTSC, though, and CRTs is that because there's not actual pixels on there, you know, you're not making an LED brighter or dimmer. You're actually just tweaking the way the electron beam scrolls across the screen. Is NTSC also technically has infinite horizontal resolution within the spec. Obviously, like Eeyore said, you've got your phosphor size is going to limit that somewhat. But the actual spec, you can technically have infinite horizontal resolution, because as long as you can modulate and demodulate your signal fast enough, you can do whatever you want. The thing with CRTs is because they have that electron beam, in case you didn't know, CRTs work by having a phosphor screen on the front. That's like right here, like right on the inside of this tube, there's a coating that fluoresces when it gets hit by like I suppose fluoresce is the wrong word because it's not UV, but it glows when it gets hit by electrons. And there's this big thing in here, if I kind of rotate this to the side, the other side, that isn't blocked by the radio transceiver or receiver. There's this kind of thing here. You can see this is the actual tube. Also, for the record, I should have said this at the beginning, but these tubes use a lot, like really high voltage, like in the kilovolts. Like I know this thing is capable of running off of 8 C-cell batteries, but it amps that up to like kilovolts, which is more than enough to start sending electricity through your skin. So do not touch, don't touch these in the wrong way. Don't take apart CRTs if you don't know what you're doing, because if you touch the wrong spot, it will kill you and it will hurt. Regardless, I'm going to keep gesturing with a metal thing. Yeah, this tube right here is the actual electron tube. So or the cathode ray tube would be a more specific term for it. But there's actually a vacuum in here. That's why a lot of the time, if you like drop a CRT and you shatter the screen, you'll hear like a whooshing noise or a big bang, because this is actually a vacuum in here. If I back this out a little bit more, I don't know how much I can move this thing around without having it like fall completely apart on me. But you can kind of see there's this little glass tube back here. That's part of the vacuum as well. So what it does is it actually makes this extremely high voltage, and it generates electrons, and it shoots electrons toward the phosphor on the front, and that'll cause the phosphor to glow. The problem though is you're just shooting electrons straight as a straight beam, you know, they ain't going anywhere. You're just getting a dot on the screen. So that's what this big coil here, you can kind of see, it's hard to see from that angle, but I really should have zoomed the camera in. Let's see here. I was going to do this when I got up and then I completely forgot. There, that's a little better. Good enough. But you can kind of see here, there's a copper coil on the top and bottom of the tube right here. And then a little bit over here, it's really covered up. I can barely see it from here. But there's another bunch of copper windings that are going the other way. So there's a copper winding on the left and the right instead of the top and the bottom. What those are for is actually deflecting the electron beam so it can scroll across the screen. So the ones on the top and bottom create magnetic fields that deflect the electron beam up and down, and then the ones on the left and right will deflect it to the left and right. So that way you can kind of apply you can put a different voltage through each of those different coils to move the beam all around the screen. If you've ever used like an Etch-a-Sketch, that's kind of what this is. For those who don't know what an Etch-a-Sketch is, they're kind of neat, little toy. I don't know. You can look it up. They're kind of cool little things. But yeah, you can scroll the thing across the screen. So what I did was take these 4 white wires, which you can kind of see here are hooked up to the coils, and I connected these wires here. I took them off of the board, the main board. So what this would do before is it would connect the output. It had 2 timing circuits, one for scrolling the beam horizontally, so it's gently ramp up the voltage, then drop down, then gently ramp it up again, drop down. And then there's one for going vertical, so it just slowly go down the screen and then back up and down the screen again. So that way you'd get kind of your scrolling motion where you just go a whole bunch of times across the screen. What I did was disconnect the deflection coils from those circuits and then hook them up to this audio amplifier, which I got off Amazon. Actually, a friend got it off Amazon, and I traded him for it for a computer power supply. I think he got the better deal, to be honest. But this thing's been kind of useful. So the reason I had to hook it up to the amp is because these deflection coils run off like 10 to 12 volts, so they take kind of a higher voltage. But what this allows me to do is it amplifies a voltage from a regular like line in to the voltage that the deflection coils need in a really nice way, since it allows me to just hook up like an audio thing, you know, standard 3.5mm TRS. If I rotate this back around here, plug this power strip in, and hopefully not kill myself. It hasn't happened yet, so I think we're okay. Let's see, if I turn this on, you're going to see a little dot show up there in a few seconds. right there. I don't know how well that shows up, but it is there. And I don't actually have anything to play through this, I don't think. Yeah, if anybody has a phone or a computer with an aux port who wants to play music, now's your time. If you want to come up here and play something. Okay, we got a volunteer. We got a volunteer. Your Mac has a headphone port, unlike your iPhone.
Only 4. And most phones don't work, so I'm gonna pass on that one. Okay, what should I play?
Honestly, whatever you want. We're not gonna hear. Well, actually, let me see. Is there a? I don't think there's a. I don't think there's an audio output here. You know what? If you want, here.
Right.
We should see the. Yeah, so you can see.
probably get it louder.
Yeah, there we go. You can see the thing moving across. If you want, here, plug this. Swap your.
No need.
Here. No, you don't want to. You don't want to. Let's see. I got these pair of headphones that I tossed into testing. I don't think these even go on.
This wasn't much fun.
But yeah, you can see the audio signal is actually controlling the horizontal and vertical position of the beam. In this case, it's I think the right audio channel is hooked up to the horizontal deflection, and the left audio channel is hooked up to the vertical deflection. So most of the time you kind of see it go in this straight line like this because they're the same, but it gets a little bit different, so you can see it kind of move around and actually kind of draw circles. I can actually, if I control the thing on here, I can actually make it bigger and smaller. Like that. I can also, this thing has like bass and treble controls, so if I tweak the, oh, it stopped.
I don't think that's. Well, I think headphones.
Oh, did they disconnect? Oh, I think it pulled out a little. Oh, it didn't. No more music, maybe try to. Sometimes that works. Of course it works. Yeah. But yeah, you can kind of see if I move the bass and treble around here, which is which. So I turn the bass all the way down, the treble all the way up. It looks really bad because since this is an audio waveform, right? Audio is like really high frequency. This is probably somewhere around like 4,000 to 8,000 hertz. That's about human speech. That's about as high as human speech will go. So if I turn the bass up and the treble down, we're gonna see. Now you can kind of see it pulse with the bass, because the bass is actually low frequency enough where the beam can actually move around a bit with the waveform. So yeah.
Really fixing up.
What'd you say? Yeah, it's a really cool thing. And while doing research to figure out how to do this, there's actually like an entire community of people online who make art using like synthesizers to like generate a waveform, pass that through filters and stuff, and then put it into TVs like I'm doing here to make art. Because if you do this with just a single like standing wave, like you play a single note, it'll actually draw out a picture on the screen that just kind of is static. So that was a bit quieter. You can kind of see when it if there's like a sustained note, it'll like hold the same thing for a little while because it's actually just the repeating pattern from the note.
They can do like.
Oh yeah, that would work. Yeah, piano,
I don't know
or
how to. I can press it.
if we can get if you guys find like a tone generator too, that would probably work as well. Or if you have like garage. Yep, you can kind of see it fades out because it's a piano, but
Oh, sustain.
yeah. Yep, you can kind of see it makes a circle there.
Oh.
Yeah. Yep, and you can see when he holds it, it kind of holds its shape for a bit before the piano eventually makes it go quiet. So, yeah, it's pretty cool. there's a lot of fun stuff you can do with this. When I originally got this TV I got from Garage Sale North Dakota. The reason I actually brought it out of my basement at my house was because during that Goodwill trip in Minneapolis where Hunter got his router, I found the exact same model of TV, brand new in a box, which is really interesting because that's the same way I found it when I found this one in North Dakota as well, which really says just how useful these TVs were back when they first came out, since both of them were brand new in the box. Yep, you can see I have noticed when it gets super loud, it does this weird thing where it kind of just goes up the center. Not 100% sure what's up with that. I think it might be the audio stuff. But yeah, I got a similar TV to this. It was silver instead of red, and that reminded me I had this broken one. And I'm like, oh, I could do some fun stuff with a broken CRT. I should go grab that from home. So when I went home a few weeks ago to, I think I went home to vote. I grabbed the CRT here and pulled it out and started tearing it apart once I got back down here, and here we are. Kind of a cool little thing. So yeah, that's what I've got. Thank you for lending your Spotify. Now I have to figure out how to get this thing back into the box without electrocuting myself. Thanks. Yeah, these things have big capacitors in them too, so they will hold charge. So just because it's unplugged doesn't mean you're not going to kill yourself. Let's see. I think I can. Oh, I'm caught. Oh yeah, the power strip's another fun story too. This thing's I don't know how old it is. Temporary power tap from I think I looked it up once. I think it was like the 70s or 80s. But I got this from my high school. I knew one of the janitors there and he gave it to me. It was broken, but I fixed the switch and now it works again. So it's a very aesthetic choice for this project. $5 headphones for the Yep, save so much money. I once found a pair of Bluetooth headphones at Menards for like $3. I used those things for a year straight. I replaced the battery. I replaced the wire that went like over the head to connect the two cups. I replaced the. I glued it back together several times. Like the whole thing broke. I glued it back together. I put nails in it and it actually hold its form. I got so much. I got my money's worth out of those $2 headphones. Let me tell you. Spend more on the battery replacement than I did the headphones.
The built-in one won by a little bit.
It did?
Yes.
Okay.